Okay, in this video, we're going to be doing polar, parametric, vector, multiple choice question practice for the AP Calculus BC exam, but this would definitely be useful if you're in any Calc II class anywhere. This is video 3 of, ultimately I will be doing 8. Parts 1 and 2 definitely exist. Part 4 almost certainly exists. 5 through 8, I'm going to get done when I can. I've already done the problems. I just need to, do it. So let's get started. All right, this is a calculator question. The instantaneous rate of change of the vector valued function g of t is given by r of t, double equal sign because of a typo, square root of t squared plus 1, comma, sine of t squared, if g of 7 is equal to the square root of 2, comma, pi, which of the following is g of 0? So this, we get to rearrange the fundamental theorem. Key thing here, and sort of weird, r of t is the velocity in this case. So usually r of t is the position. I don't know why it's defined this way, but also they're telling us the function is called g, so there's a lot going on. This, if it were a Calc AB problem, you would just kind of set up in the same exact way, right? So it'd be g of 0 is equal to g of 7 minus the integral from 0 to 7 of g prime, so r of t dt. So always you can write down normal fundamental theorem, see what it would tell you, and then rearrange it for what you need. So like the integral from 0 to 7 of r of t would have been g of 7 minus g of 0. We're looking for g of 0, so you solve. This is just the fundamental theorem, and it is my favorite way to use it. So in this case, it's a calculator question. Excuse me. So you can do it however you want. Here's one option. So to find the x-coordinate, I do radical 2 minus the integral from 0 to 7 of, dx dt, so square root of t squared plus 1. I get negative 24 point whatever. The y-coordinate is going to be pi, which is what you start at, minus the integral from 0 to 7 of sine of t squared, so I get 2.5. At that point, I know the answer. Or you could do it the fancy way that I like to do it, where I define r of t, I do the vector minus the integral of my vector valued function. Either way, it doesn't make a difference. You can see we're both getting the answer, and our answer is definitely B. All right, next up. Another calculator question. For a certain polar curve, r is equal to f of theta, it is known that dx d theta is cosine theta minus theta sine theta, and dy d theta is sine of theta plus theta cosine theta. That's annoying to say. What is the value of the second derivative of y with respect to x? So we need to keep track of what's going on. It doesn't really matter that these are polar functions at this point because we were given dx d theta and dy d theta. If we'd been given the polar function, it would have been more annoying because we'd have to say x is r cosine, y is r sine, find dx d theta, find dy d theta, find dy dx, find the second derivative. It'd be like so many extra steps. But in this case, we need to know dy dx is y prime over x prime, and the second derivative of y with respect to x is the derivative with respect to t, or theta in this case, of dy dx over dx dt, or dx d theta in this case. So this is actually straightforward. I just stored the values since it's calculator. I always store derivatives as d, whatever the name is. So if the function is f, I'll say df. Here it's dx and then dy. I use t instead of theta on the calculator because it's faster to access that. But it's up to you. You could use theta if you really want to. So I did the derivative with respect to t of dy dt over dx dt, and then divided that by dx dt, and then I plugged in 4, and it just spits out the answer. So our answer is this. I don't think I would do that differently on any calculator. So let's take a look at the next one. X is t squared minus 1, y is 2e to the t, dy dx. Pretty straightforward question. If you're doing all of these, you'll notice they're repetitive. When you start noticing they're repetitive, that's good. It means you're ready for the AP exam. So don't complain about things being repetitive. Be happy they're repetitive. I scour the old AP exams. I look at all the practice things. I find the questions. If you can do all of these, you can do the problems on the AP exam. So it's good when they get repetitive. So dy dx is y prime over x prime. Basically, we needed to know that as part of the previous problem, but now we're doing it by hand. I recommend that you find y prime first. I've mentioned this multiple times. Because you're going to, in your mind, want to divide the first thing by the second thing. So you might as well make the first thing the thing that should be in the numerator. And then x prime. So these are straightforward derivatives. So dy dx is just y prime over x prime. So 2e to the t over 2t. So e to the t over t. And, there's nothing wrong with the question being straightforward. Hopefully they all are. All right, 28, calculator again. For t greater than 0, the position of an object moving the xy plane is given by parametric equations. X is t cosine of t over 2, and y is the square root of t squared plus 2t. What is the speed of the object? So we need to know how to find speed. Speed is the magnitude of velocity, so speed is going to be the square root of dx dt squared plus dy dt squared. This question is not about arc length, but notice that arc length is just the integral of the speed when you're dealing with parametric or with vector. All right, so in this case, it's calculator, so I'll show you the way that I would do it. So I would define x of t, I would define y of t, and then I would define v of t. That's pretty annoying to do, but I do it all the time. So v of t is just the vector dx dt, or the derivative of x with respect to t, comma the derivative of y with respect to t. I have a lot of videos where I do stuff with vectors on the calculator, so you can seek those out if you're not sure what I'm doing here. And then I just find the norm of v of 1, and I get 1.319. You might not like that, in which case I did it this way. I just find the derivative of x with respect to t and plug in 1, find the derivative of y with respect to t, and plug in 1, and then I do the square root of the sum of the squares. Either way, same answer. Again, it doesn't matter how you're doing it as long as you are getting the right answer. Next up, let R be the region in the first quadrant that is bounded by the polar curve R equals the square root of 6 sine of 3 theta. As shown in the figure above, what is the area of R? Okay, so I look at that. If they didn't provide the graph, I would not know exactly what that looked like. They do provide the graph. My main question here is really, what are the bounds? Because I know exactly what to do. I'm going to do 1/2 the integral from the bounds of that thing squared, which just gets rid of the square root, d theta. So my question is, what are the bounds? I'm going to start with a rectangular graph. So I almost never graph in polar when I'm doing calculus. It's kind of weird. When I'm doing polar, I only graph in polar. But doing calculus, I graph in rectangular all the time. Here's the rectangular graph of 6 sine of 3 theta, or the beginning of it. Because the square root is just going to knock out the negative parts. And all I need to do is figure out what are the bounds for this, right? So 2 pi over 3 is the period. So then pi over 3 is here. It's a positive sine graph, so it goes intercept, maximum, intercept, and then it would go minimum, intercept, but those are negative, so the square root will kill them. So between 0 and pi over 3, I get this little hill section here, which is this when I turn it into a polar graph. So I now know that the bounds are from 0 to pi over 3. So I can set this up. I want to do 1/2 the integral from 0 to pi over 3 of the quantity squared. So the square root and then squared. But then squaring a square root just gets rid of that, which is fantastic, because otherwise what are we going to do with it? So we're really just integrating this. So this is, I don't know, it's not really tricky, but it's kind of tricky because you have a 1/2 and a 6, which gives you 3. But then the chain rule should have given you a 3. So you have a 3 on the inside and a 1/3 on the outside. The 3 and the 1/3 cancel. You're probably better off doing the work in this case, but I didn't. And then integrating sine gives you negative cosine. So I end up with negative cosine of 3 theta. I recommend you probably do a few more steps there. I like to do those things in my head, but sometimes it does get me. And I'm not taking an AP exam, so I can be a little looser with these things. Now we're just using a fundamental theorem. So it's going to be a negative cosine of pi minus negative, which becomes plus cosine of 0. Cosine of pi is -1. Cosine of 0 is 1. So it's -1 plus 1. So 2. And that's our answer. Okay, let's take a look at... So let me just remind you or review or summarize. You can look at the rectangular graph to figure out what's going on the polar graph, and we end up doing that a lot. Highly recommended skill to develop. Understand the relationship between a rectangular graph and a polar graph. Again, I have a lot of videos on that. I don't know that I'm actually going to link to all these that I'm mentioning here, but it's a good skill, and you can definitely search my channel for that. All right, what is the area of the region bounded by the graph of the polar curve R equals another one of these square root things? Square root of 1 plus 3 over pi theta, and the x-axis, between 0 and pi. Okay, no clue what this looks like, but it doesn't really matter because they said from 0 to pi, so we're just going to set it up and do it. I mean, I actually have almost no idea what that graph looks like. Probably some sort of spiral thing. All right, so it's 1/2 the integral from 0 to pi of our radical squared, And now this is a really straightforward, like you're just learning integrals type of thing. All right, so the integral of 1 is going to, so there's still a 1/2 quantity. Integral of 1 is theta, and then plus 1 times the reciprocal gives us 3 over pi times 1/2 theta squared, so 3 over 2 pi theta squared from 0 to pi. And then we're just plugging in. You don't need to watch this. So plug in pi, plug in 0, simplify that, we get 5 pi over 4. That's our answer. Let's take a look at the next one. Another polar area. So at some point I explained that I like typed up all these questions and then I sorted them into 8 separate files, and then I just got tired of doing that, so I didn't sort the problems within each of the files, so you get like, certain types in a row. I apologize sort of for that, but like you're just studying for the exam, so you need to, master everything anyway. All right, which of the following integrals gives the area of the region that is bounded by the graphs of the polar equations theta equals 0, theta equals pi over 4, and r equals 2 over cosine plus sine? So like, that's a line, so like we could have worked it out if we needed to. That's a rectangular line if you were to graph it or convert it. Doesn't really matter. We were given the bound, so it's going to be 1/2 the integral from 0 to pi over 4 of this thing squared. That's how polar areas work. So we write this down. Now, I'm going to keep going with this, but like if you just look at the answer choices, you can kind of see some weird things going on. Like part A, they remembered the 1/2, I think, but they forgot to square. So that's out. For the second one, I think they forgot the 1/2 and they forgot to square. So that's out. C, I think, is actually the answer, so they did that one right. What did they do in D? They squared but forgot the 1/2. And then in E, I have absolutely no idea what they did. I don't know. I don't even know. Maybe they found like dy dx and then squared that. That's like my best guess. How do you get that thing to the 4th there in the denominator? And where is cosine minus sine even coming from? I don't really know. So I think the answer is C, but let's I won't make you watch me simplify it. So I square it out, and then I have a 4 and a 1/2. So I end up with this, and the answer is in fact C. But you can look at the answer choices and see like what have they done wrong, which one is likely to be the correct answer. A and B you can throw out right away because they didn't square. So like that's really helpful, right? I mean, you're basically down, I think, to C and D without even thinking about the problem, because how could the answer be E? Anyway, 32. The position of a particle is given by the parametric equations. X of t is the natural log of t squared plus 1. Y of t is e to the 3 minus t. What is the velocity vector? All right, velocity vector, this is a nice straightforward question. A velocity vector is x prime of t, y prime of t. I think on a free response question, you would want to write that down to guarantee that the person reading it will give you all the points. They're going to know you know what you're doing if you get it right, but to guarantee all the points, I would write that down. V of t is x prime comma y prime. Now I got to find x prime and y prime, but these are just like normal problems at this point, right? So x prime, the derivative of this natural log is going to be 2t over t squared plus 1. I have to evaluate that at 1. Means x prime of 1 is 2 over 2, which is 1. Y prime is another chain rule problem. So the derivative of e to the 3 minus t is going to be e to the 3 minus t times negative 1, or negative e to the 3 minus t. Evaluated at 1 gives us negative e squared. That was hard to say. I just wanted to say t again for some reason. And so my velocity vector, sorry, I wrote v of t. This should be v of 1. V of 1 is 1 comma negative e squared. So there we go. All right, let's take a look. So just to be clear, that is not v of t. V of t is not like universally 1 comma negative e squared. V of t would vary. It would have t's in it. This is v of 1. All right, next up, 33. The instantaneous rate of change of the vector valued function f of t is given by r of t. So this is annoying because r of t should be a position, but that's not what we're doing. 3 plus 30t minus 8t cubed, comma, 9t squared plus 4t. So that's dx dt and dy dt, or x prime and y prime, are given from r of t. F of 1 is 4 negative 3, and we are looking for f of negative 1. Okay, so this is it's kind of a fundamental theorem problem. We're just rearranging it. I would say keep in mind that this is the velocity. So I'm just going to rearrange the fundamental theorem. So I don't know. We know 1 and -1. So x of -1 should be x of 1, which is 4, minus the integral from -1 to 1. So I'm doing minus because the thing that we are looking for is less than the initial value. So I'm rearranging the fundamental theorem. I love doing that. And then we need dx dt. So we're going to have this. And now I'm going to kind of blow through the work because it's just a standard fundamental theorem question. And you can, I'm pretty confident you can get that. So I get -2. Y of -1, we're going to set up the same thing, right? So it's where we are at 1, which is -3, and then minus the integral from -1 to 1. Typically, you would know like the position at 1, and you'd be looking for the position at 5, so you would add the displacement. Here, we know the position at 1, we want the position at -1, so we subtract the displacement because we're going like back in time. And then there's dy dt. So again, you don't have to watch me write this. I'm just using the fundamental theorem. And so I get -9, which means that my vector is -2, -9, and my answer is B. Rearranging the fundamental theorem is on the exam so many times in so many different contexts. Make sure you definitely know. It's frequently a calculator question where you like can't really by hand find an antiderivative, so you have to do the definite integral. All right, next up. What is the slope of the line tangent to the polar curve r equals cosine theta? So slope of the curve is going to be dy dx at the point where theta is pi over 6. So we need to remember polar slope is dy dx, and x is r cosine, y is r sine. It looks like we're doing this by hand. Ugh. Okay, so x is going to be r, which is cosine, times cosine. So x is cosine squared. So we need dx, I always write dt, it's really d theta. Dx d theta. I don't really think on the exam you would lose a point for that on a free response because it's like, you know, what are we doing here? We're trying to see if you know the calculus, not if you're spelling everything correctly. As long as t and theta aren't both in the problem, you almost certainly wouldn't lose a point. Maybe I'm just telling myself that, but I think that's true. I use the chain rule. The derivative of cosine squared is 2 cosine times the derivative of cosine, which is negative sine. So you get -2 cosine sine. I need to evaluate this at pi over 6. Cosine of pi over 6 is √3 over 2. Sine is 1/2. Know the unit circle. Definitely know it. So it's -2, √3 over 2, 1/2. That simplifies to -√3 over 2. And then we need to do the same thing for y. So y is going to be the polar curve cosine times sine. And then we need the derivative. This is a product rule. So dy d theta, which I got right there, is first derivative of the second plus second derivative of the first. So don't forget like the product rule when you have a product, the quotient rule when you have a quotient. People, for whatever reason, eventually like, you know, you got a lot going on, things get confusing. So we need to evaluate this at, again, pi over 6. So cosine is √3 over 2, sine is 1/2. Make sure you know that. If you walk in not knowing the unit circle, you're going to struggle on a lot of values that you need to find. And this gives us just 1/2. So dy dx is dy d theta divided by dx d theta. Typically, I will find dy d theta first and then dx d theta. I forgot to do it because I got overwhelmed by the polarness of the problem. So it's going to be the green thing over the blue thing. 1/2 over -√3 over 2. And that gives us -1 over √3, which they don't rationalize, which is good. Rationalizing is kind of a waste of time unless you're trying to match a multiple choice answer. All right, next up. A curve is described by the parametric equations x equals t squared plus 2t, and y is equal to t cubed plus t squared. An equational line tangent to the curve at the point determined by t equals 1 is. All right, so if you've been doing all of these, you have seen this multiple times now. We need to find dy dx, and we need to make sure that we don't confuse x and t. Some of my best students throughout the years have confused x and t. It's a very common mistake. Watch out for it. So I'm going to find dy dx by doing dy dt over dx dt. Got to find dy dt. So dy dt is, this is just a power rule problem. 3t squared plus 2t. And then I need to evaluate this at t equals 1. Also, I have something in my eye, which really hurts. Okay, so at t equals 1 gives me 3 plus 2 is 5. Dx dt. Again, the power rule. It's pretty common to just end up using the power rule on these. T equals 1 is 4. And so overall dy dx is going to be 5 over 4, dy dt over dx dt. And then we need to also find the point, right? That's where people screw up. So x of 1 is just plugging in, we get 1 plus 2 or 3. And then y of 1 is again plugging in, we get 1 plus 1, so 2. So our ordered pair, I think it's useful to write down the point and the slope when you're going to use point slope form, is going to be 3, 2. So our tangent line in slope intercept form is y minus 2 equals, point slope. Oh my God. In point slope is y minus 2 equals 5 fourths quantity x minus 3. That's all good. The problem is the answers are in standard form. They're not even in slope intercept form. So I don't know. I'm going to multiply everything I see by 4 and also like distribute the 5 on the right hand side. This is algebra 1, so I'm sure you know how to do it. And it's just weird that sometimes you need to do this on an AP exam, but you do. So we get this, and we got one more problem here in this set, and then I'll be back in the next video, and the others already exist. A curve is defined by the parametric functions x and y, where dx dt is not 0, and 2x of t minus y of t equals 4 for all t. Which of the following equals dy dx? I don't know. This is not a standard problem, so I'm thinking this is really just an implicit problem. I want to find dy dx, but x and y are functions of t. So I'm going to take the derivative with respect to t of both sides of this equation. Probably another way to do this. I'm not really sure what it would be. So I'm treating it this way. X is a function of t, y is a function of t, so I will get 2 dx dt minus dy dt. The derivative of a constant is 0. That's the most common mistake people make on implicit. And then I need to just rearrange this until I can get dy dt divided by dx dt. So I basically added dy dt to both sides, but rearrange it. And now I'm going to divide by dx dt, because as soon as I get dy dt over dx dt, I know I have dy dx. This gives me 2. So dy dx is 2. That's a weird problem, but you just never know how the problems are going to come at you. So we get this, and that's it for this set of 12. I'll be back in the next video to do the next set. The others exist. The other 4, I don't know, might exist at some point. But anyway, I hope you found this helpful, and good luck.